Thank you.
Thank you.
All right, looks like we have a good number of people in here, so we can go ahead and get started. So welcome everybody to our session on XR and haptics for combat medic training. I'm Shane Tabor, Development Director, Vice President of ECS. I'm happy to be here. You know, this is an exciting topic for me, both in the domain of virtual reality, augmented reality, but as well as training for military and particularly combat medicine. It's something that I've been involved with for over 18 years. When I started my career, one of the first projects I worked on was looking at mixed reality for dismounted soldier training and mixed reality using the Canon prototype mixed reality headset back then in about 2003. And worked on that project for several years and then came over to ECS. And ever since then, we've been working on combat medic training, serious games and virtual worlds, and VR for this domain. So the two images you see there is kind of the art of the possible that we were trying to do 18 years ago, and with some moderate success. But then now today, with all of the latest and greatest technologies, it's exciting to see where it's all come over that 18 years. So a quick introduction to us as a company. ECS is an innovative small business. We're located out of Orlando, Florida. We have a couple other locations in Huntsville, Alabama, as well as San Antonio, Texas, which is kind of the epicenter of Army and DHA government military medical training. Our 24 years in business has been largely focused on innovative technologies, advanced learning technologies, serious games, virtual worlds, and a lot of XR and virtual reality based solutions in the domains of medical, both commercial and military medical, aviation, marksmanship, and first responder training. So a little bit of how we got here. One of those first products that I worked on when I started here 16 years ago was the Tactical Combat Casualty Care Simulation, or what we call TC3 Sim. In those days, it was a very early prototype that was exploring how to use game-based training for learning, and which was not a very popular idea at the time. But it proved this a lot of success. There was a training effectiveness evaluation that was done as part of a dissertation within the Army that proved there was over a 10% improvement on skill retention and knowledge retention by using these virtual technologies. So it ended up forming this test bed of technology and looking at how you can do these different technology integrations and ongoing research. And as such, it's led to this continuously active development and evolving requirements for the Army primarily, but also the Marines with some training for corpsmen, and looking at integrations with other platforms like their virtual battle space and other enterprise solutions, and studies like the Squad Overmatch study, which was looking at how squads can overcome adversity and improve their resiliency. And really, this is not intended to be like a first-person shooter. It's more of a first-person thinker, and getting that cognitive training in terms of how to triage appropriately and make those decisions under stress. Recently, this has led to kind of a transition of this product line into where it can actually go into an operational state for the Army. And it's been updated, modernized over the past couple of years, and branched out from a primarily desktop-based application to multiple different platforms, including Army, Navy, multiple services, expanding the casualty models and the medical interventions that they can proceed. And this is really a non-linear decision-making simulation that is complete with a full physiology model that represents all of the vitals, physiological state, consciousness, all the injuries, and how that changes over time with how the player, the learner, the user is interacting with them in the simulation. And all of that is tracked and fed into an after action review that is available for the user to see how they progress, or have an instructor or coach kind of give them that assessment. So all of this leading up to now AR, VR, it led to a multimodal study where we looked at how these emerging technologies, the new generation of VR, this was a couple of years ago, so the Vive had just come out, and all these new products were coming to market, and it was quickly evident that these were going to be disruptive to kind of the status quo of how the military was doing their training, in particular for the domain of medicine. And so we started looking at all of these different potential use cases for leveraging VR, MR, and AR capabilities to demonstrate how these immersive training solutions can advance these different areas of training, such as standardized patients, increasing engagement and skill retention, simulating things that are rare or hard to reproduce, either costly or risky to reproduce in live or virtual lane training, as well as provide something that's a little bit more intuitive for many users through natural user interfaces. So ultimately, this led to a lot of prototyping in VR, where we leveraged a lot of the baseline functionality from TC3Sim, a lot of the content, and brought that all forward and looked at an assessment of all the different skills that are available in the TC8800 doctrine, which is the Army doctrine for combat medics. And we looked through that whole doctrine and found skills that we felt matched well with how to evaluate the technology at the time. So we looked at a blood sweep, which is really where the combat medic goes from head to toe on the casualty, manipulating the body, sweeping, looking for blood or injuries across the whole body. So it's very gross movements, moving limbs and rolling back and forth. And then we did the combat application tourniquet, which is one of the primary interventions in the battlefield, and that involved cranking a windlass, working with straps and Velcro, a little bit more of that fine motor skill. And then we ultimately looked at the needle chest decompression, and that's where you find an intercostal space in the rib cage. You insert a catheter tube, and then you put a needle in there to draw out the air that's trapped inside of the chest cavity. That's a very fine motor movement. And we developed those as like task vignettes, and expanded that. And all three of those scenarios proved very effective in how they, even with the technology at the time, and proved a lot of promise for how this could be used. So this led to doing an even further evaluation of the technologies that were emerging and coming to market in that time that we were doing that analysis. So we started looking at the breadth of those, from high end to low end, that enterprise system to prosumer system, and all the way down to kind of a consumer level. Everything including glove-based systems and non-glove-based systems, tethered systems and wireless systems, and various levels of fidelity, because what we wanted to look at was what is enough to meet the requirements for the training need for various skills. So there may be some skills that require a really, really high level of fidelity, really high level of accuracy and feedback. But then there may be others, like those gross motor movements, that maybe don't require that high of a level, and can be done either in a more cost-effective way or a more portable way that doesn't require as large of a system. Through all of these integrations, tests, and evaluations, we encountered a lot of technical challenges. Some of those involve, the tracking and calibration. That's very important for these kinds of immersive simulations, because that proprioception of, hands-on training, tracking the hands and the fingers, as you're working with things, if those fingers aren't where you expect them to be, then you start to, remove yourself from that suspension of disbelief. As well as a lot of these scenarios require a lot of movement and mobility. the combat medic or the combat lifesaver that's having to respond to threats and move casualties out of harm's way need a lot of space to be able to do those interactions and to be able to do that in an intuitive way that's not gamified with teleporting and things like that that would break that immersion. We needed to use large spaces like you see there in the photo, as well as dealing with just kind of the common developer issues of working with different hardware. A lot of this hardware was early access or development kit type hardware, as well as the various software development kits that were also many times for brand new technology were in various states of completion or alpha beta production status, and then figuring out how as we develop scenarios across these different platforms, how do things like prop interactions with virtual props with the physics in the game engine, as well as physical prop interactions, how do those interplay with the gloves and the limitations of a glove that's bulkier than another may preclude you from using a certain type of prop interaction, or may not feel as intuitive to the user. And then things like compatibility, is this sensor compatible with another platform? Is that, is there any kind of interference involved and things like that? So working with each of these vendors and manufacturers and developers of these technologies, and to really push the limits of what is possible with those combinations. And then even things like the human element of hand sizes. You have different gloves. Some gloves fit better on other users, and you might, the manufacturers shoot for, that 60 to 80%, but then you end up with some users that are just outside of those ranges. And how do you accommodate for that, both in the scenario and the technology? And then throughout all of this, we're continually, more of these technologies are coming to market. So it requires that constant assessment of what's coming out, how does that map to the research we're doing, the gaps that are in the training needs, and where it can fit into other existing technology integrations. Some examples just in the past recent years, we started looking at the VRARA XR1, and then while we're doing that, boom, the XR3 comes out. So it's like, okay, well now, does it warrant advancing to that one because of the capabilities it provides? There's also those, development kits that are advancing to production units. Usually that's a good thing, but it's still change in development environment. Things like haptic vests now are becoming full haptic suits. And then just the big question mark of what's next, full body force feedback, or, who knows? So it just requires that kind of constant reassessment, reevaluation throughout the process to make sure that these are being considered in the ongoing research. And speaking of ongoing research, we have multiple projects right now that we are tackling all of these across different parts of this problem set. Everything from advanced haptics, looking into how this fits into outside of the battlefield, getting into more of the combat field hospitals and more into the surgical care and that kind of clinical care, as well as moving more into the combat arena where there's care under fire, where a combat lifesaver or combat medic is going to have to respond to threats and switch back and forth between treating a casualty and making sure that they are safe and the casualty is safe, and that they're responding to threats appropriately, because ultimately they're a soldier first. So, and with that, I'm going to hand it over to Nathan Guinness, who's the project manager for some of these projects and our VP of Huntsville operations. So with that, Nathan.
Awesome. Thank you, Shane. As Shane said, I'm Nathan Guinness. I head up our Huntsville, Alabama branch office. That office primarily focuses on aviation, aerospace, space, missile defense. But I've been asked to be PM on several research projects, one of which I'll talk to you here now. And let's see, Shane dropped. So I guess, oh, okay, never mind. You're still working the slides. I just didn't see anymore. So no worries. So yeah, the most recent project, or the project I want to talk about here, is an augmented reality research project we did for the U.S. Army, and specifically, we were looking at care under fire scenario training and how best we can leverage AR and VR capabilities to do a large or relatively large scale training event. Because as Shane alluded to, we've done a lot of the fine motor skills in VR using haptic devices and such. We've done limited AR individual tasks, but on this one, we ended up going to the combat medic training site and see kind of the culminating event for what's called the 68 Whiskey occupational specialty training. And in there, they do small group, squad, and team elements, movements through a training lane that involves decision making, because as much as they do get graded on the actual medical tasks they perform and the security tasks and other individual tasks, really this one puts it all together. So as we looked at and observed the training, it was all about how you use the resources, the situation awareness you have at the time, and put it all together. So on the slide, you see kind of the technology-based research questions we went in there looking at. Essentially, it comes down to how we can leverage the technology to make training either more realistic, more accessible, or just overall better. The image you see on the slide is one of the products we ended up developing as part of this. This is the AR view from a HoloLens 2 of the training site we put together in virtual space. Next slide. So as Shane was talking about, instead of doing a first-person shooter or a first-person task trainer, the big thing was shifting the training to the cognitive levels and decision making. So we wanted to look at not just decisions they needed to make, but kind of dial down into why the individuals in the training event were making the decisions based on their knowledge, their skills at the individual tasks, and then really specifically hitting their awareness of the overall picture in this situation. One of the critical driving factors we saw is how much either the representative squad leader would adjust the scenario, or the instructor, if they didn't have a representative squad leader, by pulling levers and strings such as adding casualties, removing casualties, having casualties be able to self-treat, or adjusting the time that the medic has to triage the casualty in order to scale the difficulty to meet the needs of that individual going through training or the collective team. Next slide. And looking at kind of continuing with that concept, we also wanted to expand beyond the roles we'd traditionally trained, because we had the TC3 sim for years looking primarily at a medic responding to events within his or her squad. And some of that also topped on to, combat lifesaver, which, if you're not familiar with combat lifesaver as a term, that's essentially just a soldier that has basic kind of level first responding medical triage tasks, and they're kitted out accordingly, but they don't have the capability, the full training and capability to be a combat medic. Then we also looked at being able to incorporate the squad leaders and kind of the entirety of the squad, as opposed to traditionally our training had focused on kind of one individual going through there. So because of that, we came up with a multi-platform design that we ended up, for the prototype and starting the build to kind of neck down and make it easier, it's locally networked through a wireless network. So the delivered feasibility demonstration I'll talk to on the next slide, we ended up having a security element represented and an instructor workstation. The security element is in virtual reality using a haptic instrumented M4 to get haptic feedback while they're engaging targets. And the VR device they used was a tethered 5 Pro. The instructor station, in order to be able to kind of look and see the entire battlefield and adjust the scenario, we used HoloLens 2 and put that in an isometric perspective in augmented reality, which you'd already seen a representative image of kind of what that space looked like. And as this research expands, since we completed phase 1 and we're in the process of going to phase 2, we're then going to incorporate some of those medical tasks we've done before and add that using either VR or AR, depending on how it best meets the training needs, and then incorporating haptic gloves in the form or provided by VRGlove. And then with this platform we're building, kind of, as others have probably seen in challenges or in their experience, as you start building even local networked, it is in the realm of the possible to start expanding that to actual delivery over the internet. And then, an AR workstation for the instructor doesn't necessarily need to be co-located. So then you get into telepresence, teleteaching, remote assist, potentially looking over the shoulder of people operating in VR or AR space in order to gauge and adjust training tasks. Next slide. So just to cover the images, since they're kind of heavy if you haven't seen them before. These are captures from the HoloLens 2 showing the AR overlay that the instructor has access to. The bottom right shows the scenario with where the hand is pointing at is the individual going through training in the security element right there, and then you see the red indicators for the enemy. Up top, you see what you have the session details and then real-time player data that's gathered as they go through it to see. This one is focusing on the security element, so it's looking at rounds that they have currently on hand, engagements they've done, whether they've been successful and how successful, and their shooting accuracy and all those sorts of data. But the goal is to be able to have dynamic builds and adjustments of the scenario, just like we saw in the real training. So from the instructor workstation, before you hit play, you can set up the scenario, place the enemy where you need to, mark out which casualty and which type of casualty the team will experience, and place that, and then really set the conditions and hit go. And then right there, it immediately goes live, and your security elements in virtual reality sees the enemy and starts engaging, and then the medic starts triaging casualties and such. And the squad leader can adjust it through levers in the device by adding, subtracting enemies, adding additional casualties, changing the casualties. And then all importantly, they can communicate by adjusting the time remaining to complete a task. Because of course that's really critical, because a lot of times in a squad moving to contact, when they take a casualty, they'll set the parameter where, hey, we only have 5 minutes to triage the casualty before we have to get out of here, because we're either going to be overrun or the mission's going to pass us by. And so that is one of the key stressors. So then the medic will need to adjust how they treat the casualty in order to do as much as possible to stabilize that casualty and prep them for movement in the time allotted. Next slide. And so we delivered this as a feasibility demo. Just instead of having everything networked in a full squad, we had, you see in the top right, that's our lead engineer on the project demoing from the virtual reality security element. And then I'm at the bottom demoing the instructor workstation to the target audience, and we captured it. You see the image, the lower image, the left side screen is the VR view, while you get the AR streaming view in the kind of the top of that image. And one of the feedbacks, or the best feedback we got on it from our delivery to the government, that we really kind of made the team really excited and really showed that we're kind of onto something. We're kind of the bottom three bullets where the general feedback was it was great how the instructor could adjust it from, based on the needs of the training audience. So if the team was well oiled and working really quick, they can ramp up the difficulty. If the team's struggling, then instead of just having a poor exercise where everybody gets frustrated because maybe it exceeds the capability, or they're fumbling with the technology because it's their first time going through it, they haven't used it before, then you can ramp down the difficulty. And then as they start getting more comfortable, you can ramp it up. And then the real neat part is the scenario is malleable enough, even at the feasibility level, that you can really tailor it to the needs of your training audience. So if Nate Guinness and my squad are going through it, and I operate in a certain theater with a certain threat, I can set the parameters as the squad leader instructor in there to really hit our training objectives. And just like, if somebody else is going through, they could change it completely. And that's already shown in the feasibility demonstration. Next slide. And so the feasibility demonstration kind of culminated the phase 1 research with the goal of the feasibility being to show proof of concept, saying that this is a viable course of action. The technology does actually enable different training, and then we're going to expand that upon that in the phase 2. So the biggest thing we want to add in phase 2 is really adding in the medical component. And as I mentioned, that's going to be with VR Glove. Part of the reason why we didn't have them in the really two reasons why we didn't have them in the feasibility demonstration. One, the customer we were working with from the government is already very familiar with our very hands-on task trainers for the medics, so they're very comfortable with our position and delivery on those. And then also, kind of as Shane alluded to, we've been hand in hand with VR Glove the whole time. We've worked with them before on other projects, and they're right at that threshold where they were transitioning from a pure development research prototype to their first delivered model. And so we worked jointly with them and made a collective decision to wait and include the VR Glove in phase 2 when it's the actual production model versus any prototype development kit. And then the other part we were really going for is grabbing the real-time data we have and starting to put it in a data record storage, which is searchable by the individual team and soldier going through the training. And then that's kind of really this project kind of in a nutshell. I do see the questions coming in. That's why I've paused a little bit, but I think I'll pass it over to Madison to talk through our research and such, and then we'll loop back around for the questions at the end. All right, Madison.
Awesome. Thank you, Nathan. Hello, everyone. My name is Madison Quinn. I am the research analyst here at Engineering Computer Simulations. I'm going to briefly talk about some of the completed research we've done. Shane previously talked about the work with Haptics and VR Glove, where we did the needle chest decompression, the combat application tourniquet, and the blood sweep scenarios. We refined those scenarios with informal user groups, including medical subject matter experts. We also conducted multiple formal usability tests with final scenarios at different sites across multiple user groups. If we go to the next slide, we're going to see some of the results from this. Specifically, one of them is a quote from one of the users. They said, as a first experience using VR, the ability to do procedures without expending material is awesome. Some of the controls are a little wonky, but having the ability to be immersed in the environment with no risk of harm was nice. So that's a really good feedback for us. You can also see we have a graph comparing the VR Glove and the Haptics model. And then we did a qualitative analysis on word frequencies. Specifically, on one of the questions was there anything that stood out as far as the haptics during your training experience? And those are found in that chart right there, where realistic was actually mentioned 9 times, amazing was mentioned 4, impressive was mentioned 3 times, as well as great, and then real was mentioned twice. So that's really good feedback for us to know that this is development we're working on is really helping them. Can we go to the next slide? And this slide has a lot of information on it, but it's really good information to know. It's our Likert scale, which was on a 5-point scale, 0 being not at all to 5 being strongly agree. And overall, we had some really good feedback on being in that agree range. Specifically, I highlighted virtual reality training with haptic gloves can contribute to my learning skill and development, was rated on 4.38. So that's really good to know what we are making is going to help their training abilities and being able to understand the technology that they want to move forward with. If we go to the next slide. Now, these are some research questions that we're currently working on answering with one of our other projects. We're looking at performance measurements. So we're seeing how is this technology increasing their realism in the experience, and maybe what kind of mix of technology should we use? Should we use a certain type of glove with this weapon or vice versa, or should it be a solo to get the skill across? And then another section we're looking at is the instructor impact. We want to know how the instructors are feeling about this, because at the end of the day, they're the ones training this. They're going to give us the best feedback on how they believe that the individual should learn. So what are their concerns? What impacts do they think happen? And then we're going to take that information they give us and develop it a little bit further. And then if we go to the next slide. And then we'll be talking about how currently ECS works on a large development idea. Nate previously talked about this with that crawl, walk, run method. That's a system that the military uses, where they start off a little small and then they develop it bigger to be a harder scenario. And we're looking at using that in skills with like medical scenarios, combat scenarios, and then we're also going to be measuring their marksmanship during these scenarios. And if we go to the next slide. Something ECS is focusing on right now is specifically assessment versus training. We have a couple different projects that work on assessment and a couple that work on training, and we want to make sure that that is being completely separated. Assessment is looking at their grading capabilities, after action reviews, instructor overrides, and no assistance during these scenarios. Making sure that this scenario is seamless. If they've been trained on this, they know how to do it. They can go into this scenario and complete it. Versus training, we're obviously adding in those cues. We're reinforcing correct actions, audio and visually. Remediation for incorrect actions, immediate or even during the after action review with the instructor. Then we're also adding other characters into the scenario, like a squad leader or another soldier to help them move along as they walk toward it or giving out audio commands. And then also having the after action review with the instructor, because we want to make sure that they understand what they're being trained on is also going to be in that assessment, so they'll be the same after action review. And if we go to the next slide. Some challenges that are currently happening are, I'm pretty sure everyone has had to deal with these, the safety protocols, having to wear masks in those headsets, as well as staying 6 feet apart. We are making sure that during our testings, we have accessible hand sanitizer and that we're cleaning all of the equipment before and after each participant use. So if they're using the headset or if they're using gloves, we're making sure we clean those off really good before and after the participants. Another challenge is finding the right technology to mediate performance shortfalls indicated from and by the research data. Another challenge is access to subject matter experts and travel restrictions. We've been working with our subject matter experts very closely using Microsoft Teams and phone calls for interviews. And they've been able to provide us documentation and image references that we would normally collect on site at those military bases, but just due to the restrictions right now, we're doing them strictly over online and phones. If we go to the next slide. Some current and upcoming studies we've got going on. We just completed one of our alpha testings that went really well, and then we're going to be taking that information, compiling that data, and then we'll be moving it on to the usability testing at the Fort Indian Town Gap in the next couple months. And then we're also going to Mayo Clinic at the end of August to work on a burn care scenario, which is pictured right there. And then we're also doing a training effectiveness evaluation on care under fire burn care next year, and I'm looking forward to that. And with that, I will turn it back over to Shane. Oh, Shane, you're muted.
Yeah. So, you know, that gets to kind of the culminating challenge statement, vision statement, as we wrap all of this up. You know, through all of our work and investigation, analysis, and integration on these technologies, and working with our government customer, what it's really proven is that the current state of these technologies, even the ones that are embryonic or the ones that are farther along and moving to production, they all really show that the potential for these technologies being influential, disruptive, and integral to ongoing training requirements for the government, the military, and specifically military medicine is already proven. So they're being used in their current state to help define what those use cases are, what the requirements are going to be for how these systems potentially get integrated in the future. But as we go forward, a lot of this will really focus on these operational units, or the ultimate systems that get fielded in the near future. For example, for military training and the rigors of military environments, both operational and training environments, will require very rugged, tough, resilient systems that will not require a lot of maintenance and logistics and other issues in those kinds of fields. It gets into those non-functional requirements of portability and sustainability and all of that. So those will become more and more important as they go forward and transition from proofs of concepts to prototypes to actual fieldable transitioned technologies for training. And with the medical domain, these systems will need to, while doing that, will need to maintain a high level of accuracy and fidelity, because the medical domain has so many tasks that require that high level of precision, of high level of fidelity, to be able to ensure that we're not incorporating anything that's possibly negative training. So you wouldn't want a training scenario for a combat medic or a surgeon to allow them to train and succeed in training while being kind of sloppy, and then have that carry forward to live training or potentially even a real patient. So we need to make sure that while we're integrating these hands-on training solutions, that the systems make sure that they're as accurate as possible, so that the training simulations and the training content can facilitate that and make sure that the training is where it needs to be. And then as a developer, what we're seeing is that throughout this whole ecosystem, throughout this whole community, the developer community, developing the content, the training content, as well as the OEM manufacturers developing the hardware and the systems and the integrations platforms for these products, are going to need to continue to drive towards better standardization, interoperability, because none of these systems are going to stand on their own, especially in this domain of military medicine. They're going to need to be a suite of systems that all work in concert with each other and integrate seamlessly. And to do that, we really need to work on better industry standards, and so that each implementation isn't just all one-off, and then we're just trying to put everything together as developers and content developers, and doing one-off solutions for each different platform. Because as we mentioned earlier, those platforms are constantly evolving, they're constantly changing. Some leave the market, some come to the market. So in terms of that, they need to be interoperable, so that, especially for this domain of military medicine, that they can be used with each other as efficiently as possible. And with that, I think we'll wrap it up and turn it over to questions. I know Nathan's been answering some of them on the chat, but are there any others, Nathan, that we can talk about? Or if anybody else wants to drop some in the chat or the Q&A section, we'll be happy to answer them for you.
already answered the ones in chat, and for Josh Hawthorne, yeah, if you want to drop me a line or whatever, we could probably work something out where some of our team or I could answer questions about like the different gloves we've used and stuff, and because we've, I think, touched or used or had demoed probably the majority of them, and so they all have their strengths and weaknesses, and it is the key critical task is kind of finding the right tool that gets you to the right implementation, and sometimes you don't always get a perfect fit, but you get a good enough fit. And that's kind of like what Shane was talking about making sure that you get the tasks that we're trying to train to the fidelity that is required to hit the training and objectives. And you don't shortchange that, because you don't want to have something where, hey, when they're in this virtual world, they're doing 80% of the task because of the limitations of the hardware, and their primary training is going to be through that, so they're less proficient than if they were doing regular training and such. And you definitely want to avoid anything that's like negative feedback, negative transfer of skills. And that's kind of like I answered part of the reason why we went with VR Glove is because its ability to quickly transition from doing the medical tasks with the gloves on and any security tasks. So in the realm of the possible is to have, the medic being part of the security element, putting out fire, and then have to secure their own weapon to triage the casualty, because you don't want to have something like like the Haptics gloves are a pretty obvious one, that with their high instrumentation in and around the fingers, that you wouldn't be able to get those gloves into the well of an M4 normal kind of trigger mechanism without either modifying that or not having it and using haptic for it. And then that's a trade-off of whether that skews the task you're trying to train too much, that it becomes problematic, or if it's acceptable, as an example. Shane, you want to take the one about beyond military medicine, because I know you touch a bit more of that with like the stuff we're potentially doing with multiple police departments and first responders and such.
Yeah. So, yeah, absolutely. I mean, the focus of this talk was military medicine. We kept most of what we were talking about and presenting here focused on that. But yeah, absolutely, we are looking beyond that. We're looking at the aviation domain. We're looking at marksmanship. So even just outside of the the combat medic or combat lifesaver domain. As well as social justice and several other of areas that are relevant today and to both our government and military customers as well as commercial. So yeah, we're looking at the breadth of what can be used for VR, because it's the new normal. I mean, it's the future. So. All right, any other questions? See, we still have about 20 people here. A couple are dropping off, but otherwise, I'll put our contact information up here. Like Nathan said, feel free to reach out to us directly, either over email or through the hop-in platform in the conference. So we'll be happy to answer any questions you have or discuss anything. And again, thank you all for attending, and we appreciate, and we're excited to be here.
Yeah, absolutely. Thanks, everybody.